Welcome back to my YouTube channel. Today we'll be dealing with mathematics paper 1. This is an IEB 2024, right? It's a November paper. By the way, if you have not subscribed to my YouTube channel, please subscribe and click the notification button so that you'll be notified whenever I post a new video. You can feel free to comment and to share. Let us attack the following questions. With section A, which is question 1. We've given solve for x, right? So you have to solve for x. We've given number 1. What we're given there is x over 4 minus 1, right, into x plus 2 is equal to 0, right? So x over 4 minus 1, right, must be equal to 0, or x plus 2 must be equal to 0. Therefore, if you manipulate, you'll take that one the other side, then you multiply by 4, you'll have x, then you transpose that 1 there will be positive, then you multiply by this 4 that side. If you multiply by 4, 4 multiplied by 1 is simply equals to what? 4. Or take to transpose to this other side, x will be minus 2. So we'll have x as 4 and minus 2. Right. Number 2, we've given use the formula x. This is a quadratic formula to solve for x. If 2x squared minus x is equal to 12, show all your works. Supposed to show all the works. Then you have them. We have 2x squared minus x. You can take this to the other side, it would be minus what? 12, 0, right? Then you know quadratic, you know the form of a quadratic. A here will simply have a to be equals to 2, and b will be minus 1, c will be minus 12. So yeah, x is equals to, we use that formula already, it is there. We can strictly just substitute straightforward because we have already they have given us them. We have minus, then b is also minus 1, right? Plus or minus the square root of minus 1 squared into root 4a, it was what? 2, then c it's minus 12. So this is what we have there. Then we divide this by 2a, which a is what? Is 2. Then this is what we'll have, right? Therefore x will be equals to 1 when you multiply that. Because you're supposed to have 2 digits, right? This will be, you'll either will have plus root 97, 2 times this will be 4. See, our x will be equals to 1 minus square root of 97 over 4, right? Therefore x will simply equals to 2,71, or x will simply equals to minus 2,21. So yeah, that is how we attack that for marks. So number 3 says solve for x if x squared plus 2x is less than or equal to 0. We have x squared plus 2x less than or equals to 0. As you can check, this is a parabola. It's just that c here, c is equals to 0. Actually, this is a parabola. So it's negative, where if you scratch, you do the scratch like this, your parabola, you will be, the value will be negative. Remember, it's less than 0 or equals to 0 here at the turning points. The turning point is included there at the turning points. It's negative below. It's here, is that region. Remember, this is a parabola. It's just that C there is 0, right? So we can take out the common factor here, which is x. We left it plus 2, greater than or equals to, less than or equals to 0. Therefore, we know that if we can take critical values, we know x supposed to be equals to 0. X supposed to be transpose, that will be minus 2, right? So from this cache, you can draw like this here, minus 2, it is more with smaller, then we'll have 0 here, then right, so it will be negative at this region, will be between these two. So will be from negative, will be greater than or equals to, okay, x will be greater than or equals to minus 2, right? Is greater than, is between this region, also is less than or equals to what, 0. This is what we'll have there. Right, so B says determine the value of k for which the roots, I've given the roots of x into 1 over x plus 2 is equal to minus k squared are equal, right? They were talking about equal roots, right? So we know that, okay, you can simplify that first. I can say we have that x is to 1, 2x plus 2 is equals to minus k squared. I can distribute like this. I will have 1 over 2x squared, then plus 2x, then I can take that to the other side, it will be positive k squared, then they will left with 0. As you can see, this guys, it's a parabola anyway. Then we know that when the roots are equal, it's when the delta is equals to 0. It's when the delta is equals to what? To 0. And then we know that delta is given by what? By b over 4 ac. This determinant there, you remember, we'll have b squared minus 4 ac. This will be equals to 0. Fine. Then here we have our b. As you can check there, our b is 2. So they will have 2 squared minus 4. Our a, there it's 1 over 2. Be 1 over 2. C will be k squared there. Then we'll substitute this by k squared. This is what this will lead is equal to 0, isn't it? So this will give us 4, right? 2 squared, then when you multiply, this will simply equals to 2, because this 2 goes 2 times to 4. Then we multiply 2 by k, we'll have k, we'll simply have k squared is equals to 0. Then I can take that to the other side. I will have 2k squared is equals to 4. Then I divide by 2 both sides. This will be what, 2. Then I take the square root both sides. If I take the square root, will be k square will cancel with that. We'll have plus or minus. Remember, when you take the square root, you have plus or minus, isn't it? We'll have plus or minus there. the square root of 2, isn't it? Plus or minus the square root of what? Of 2. That is the value of k. Right. Now let's check question 2. We're given question 2. I've given a solve for x in terms of y. They say in terms of y. If we have given there, if 3x plus 2 there raised to the power of x, and it's what I'm trying to say there, plus y, we have simply this will be equals to 93y divided by 27. So here we'll apply just the laws of exponents. Okay, this side we still have this there so far. The other side you can change 9. 9 is the same as raised to that, then you multiply by 3y. This will simply equals to what? If we multiply them, will be 6. So they will have 3 raised to the power of 6 what? 6y over 27 is the same as 3 raised to the power of 3. Then if we apply the laws of exponents, you know the bases are the same. When we divide, we subtract the exponents, isn't it? So this will simply equals to 6y minus 3. Then since the bases are the same, again we equate the exponents. This will be x plus 2y is equals to 6y minus 3. Therefore, if you solve, you take those to the other side, right? You'll have your content there. You'll have that x. Then there we're supposed to have what? To calculate x in terms of y. Will 6 minus 2 will be 4y. Remember there we have there minus what? Minus 3. So that is what we'll have there, right, in terms of y. Then b solve for x. If we have given there the square root of x plus 8 minus x is equals to 2. So how can we solve this? You'll say like this. You'll transpose there, or you'll add that side. You'll left with, you'll have, then that will be positive when it gets to that side. But then also, how can you get rid of the square root? It's a matter of squaring, but remember the laws of maths. What you do on the left hand side, you must also do on the right hand side. We'll square both sides. Then we know this and this mathematical will cancel. We'll be left with x plus 8. Then that side, as you can see, that is a perfect square. I will square the first. I will have 4, right? Then I multiply the 2. I will have plus 2x. Also I add this. I'll add that 2. Then I multiply, I square the last, will be x squared. If you like, you can expand this to 2 brackets. There is no problem. Then distribute like that and use the law of distribution, no problem. So let me try and make things right. So okay, it's fine. Here I'll take all of these to that side. I'll left with 0. Then okay, here I will have x squared, right? Then here we'll have minus that. If I subtract that and then I subtract, this will be what? 4x. Then subtract the x, there will have plus 3x, isn't it? Then here is 4 minus 8 will be negative 4. So this is what we have. Then it's a matter of factorizing. Yeah, it's a matter of factorizing. So what are two values? You have 4. What are two values when we multiply them? they must give us minus 4, but when we add, they must give us the middle term, which is 3. Which are those two values? Those two values will be 4 and negative 1. So 4 multiplied by negative 1 will be equals to minus 4. When you add, will be equals to what? Positive 3. So it will be plus 4 and minus 1. Therefore, x will simply equals to minus 4, or x will be equals to 1. So yeah, this is what we have so far. Then now we have question C, which is the laws of logs, logarithms. If we have given if log 6 is equal to x, they tell us that those are the same then, and log 3 is equal to y. So it's determine the value of each of the following in terms of x and y. Right, supposed to find this in terms of x and y. Right, so we have there number 1, the log 18. If you can check there, we have log 18. Right, so how can we rewrite log 18? Log 18, remember, we must rewrite this. We cannot just rewrite anyhow, but we must rewrite it. We must relate it to what we've given. We must try to make our things to become log 6 and log 3 as far as possible. So how can I change this? Remember, from the laws, this is the same as log. I can say log 6 plus log 3. Remember the laws of logarithm. Log a plus log b. You multiply this, right? You'll multiply that, will be log a multiplied by b. We'll use those laws there. Remember the laws of logarithms, the ones. So but now we know what is log 6 is x, so this will simply equals to x plus log y. Log 3 is equals to y, so this is what we'll have. We're supposed to make this to become log 3 or 6 is vice possible. So I can rewrite this. This is a set, it's the same as 1 over 2. Then you know the rule that say you drop the exponents. Simply drop the exponents. You'll have, sorry, yeah, I want to say that you drop that, you're left with 3. So we know 3 is equal to what here? It's equals to y. So this will simply equals to 1 over 2. This will be y. So yeah, so now we're good here. Then we have log 2. We don't have log 2, but must try as far as possible to have what to supposed to work with what with log. It is what we are given, log 6 and log 3. So how can I rewrite this? I can say, you can say, okay, how can I rewrite log 2? But I don't have to change this. If I can say 6 divided by 2, remember 6 divided by 2, I have not changed anything. Remember 6 divided by 2 is simply equals to what? Let me check. No, that I will not 2. Remember that will be 3. Okay, let me say 3 because we're supposed to work with 6 and 3 is possible. This will simply equals to 2. We have not changed anything so far there, but we know the laws. We remember the logs. This is simply equals to log of the first. Subtract, remember this, the log of b, like that. We use that law there. So this will simply equals to log 6 minus log 3. So yeah, but we know this is x, log 6 is x, but log 3 they say we should have that. So this is what we have. so far. Question 3, guys. Question 3 says A, using first principle, find the prime x if uh, f of x is equal to that x squared plus 1. So working with our, remember this is a first principle, right? So we differentiate but using first principle. I know the formula. This is equals to lim as h approaches to 0, then we'll have f of x plus h, isn't it? Subtract the original function f of x divided by h. Then you can do it separate if you want. You can start with that then and come with that, but so far I will just put, remember, do not confuse yourself. If you don't like, you can take it step by step like this and come with that, then substitute in the formula. But I'll take one, I'll put all of everything one time, but do not confuse yourself if you find it confusing. So lim h approaches, we know that, to 0. When, remember, this f of x, remember f of x is this guy, but now when we see, where we see x, we'll replace with x plus h. So so there will be simply equal, we'll have that, we'll push by what power will be there. If we replace that, we put it there, we'll have x plus h, but remember we had that square there, then we square and also have that plus 1 there that we had there, plus 1. Then we subtract the original function, which is this, will be, because there are two terms, be careful, put a parenthesis or bracket, whatever you call, but parenthesis, then will be x squared plus 1, like this. Do not forget your h. Do not forget your h. Then as you can see, this is a perfect square. You can expand that. If you square the first term, there will be squared, then you multiply, then also you add by what you have multiplied. We have 2x squared, the last, plus h squared here, plus 1. Then you distribute the negative, will be x squared, there will be minus 1. This is all over what, our h, right? Okay, also this lim, you're supposed to continue to it until to the end, right? Sorry about that. You must continue with this lim thing. You must continue saying lim h approaches to 0. So as you can check, this and that will cancel, also this and that will cancel. Actually here we'll simply have to it lim x approaches this, we'll left with that, with 2x plus h squared all over h. Then on our numerator we can take out the common factor, we'll have lim, again h approaches to 0. Common factor there is h, you'll have h into 2x plus h there all over h. This h and h will cancel, then you substitute your 0 there, but do not show them. What we'll have there's an answer there, we'll simply have 2x, and then you're supposed to check your answer using a derivative. If you differentiate this, will simply equals to 2x, so you're good to go. Yeah, then now we have B, says find the gradient of, yeah, that's first derivative, or find the gradient of this equation, or let me just say the gradient equation. In other words, in its language they simply say find the gradient equation, but anyway, find the first principle of this equation. So we we are given the f of x is equal to 2x raised to the power 4 plus, you can rewrite this. This is the same, will be same as remember, this is 1 into x1 over 4 minus 4, but now supposed to be careful there. Remember, supposed to apply the power rule. Take this to the top, will be negative. The exponents will change and be negative 1 over 4 minus 4. Now we can apply our power rule. Our power rule, you can recap. Let us review power rule. Power rule says if you have given a, like say for example, ax raised to the power of n, right? This will simply equals to what? You multiply by the exponents, will be n multiplied by what? By ax. Then you subtract the exponents, there will be n minus 1. So let us review. Let's say now we have given 2x raised to the power of 2. You multiply by the exponent, you'll have 5. You subtract 1, you'll have this. Let's say you have given 6x cubed. You multiply there, 6 plus times 3. Then you subtract the exponents, they will have 2. So as you can see, this is how the operation takes place there. So take that first derivative, you multiply there, right? 2 times that, isn't it? So the operation will have 8, subtract 1, they will have 3, plus, okay, you multiply by negative 1 over 4 here. Also you subtract 1, will have minus 5 over 4. Then obvious, this is a constant, will simply equals to 0 here. So you can even not, even if you don't show, it's fine. So this is what we use it, guys. So yeah, that is our equation for gradient, which is the first principle. Fine, which is the first principle. So see, we have given in the diagram below, given to what f of prime is equal to x squared minus 3x minus 4, right? Which is okay, it's a parabola. A and B are x-intercept of f. A and B are x-intercept, and then they say D is a turning point of this graph. So far this is what we know. Then A says determine the coordinates of A and B, which is, remember, this is our x-intercept. At x-intercept we know y is equals to 0. So we've given the x squared minus 3x minus 4. So this is our equation. What I'm doing, this is simply just our equation. So yeah, y is equals to 0. Then you solve the matter of solving for your math. There you'll have x minus 4x. What is the value that I can multiply? Okay, I can multiply, okay, will be 1 like this. Therefore x will simply equals to positive 4, or x will be equals to minus 1. So those are the values. This is our, but they say they wanted what the coordinates. Therefore coordinate there of a, the coordinate of a there will simply equals to, because it's on the negative region, remember this is a negative region, that must be minus 1 is to 0. B will simply equals to 4 is to 0. So yeah, those are our coordinates. Then determine the turning, or the coordinate of D. This is a turning point, it's a maximum, or you know, it's a gradient. It's when the gradient there, it's where we have the minimum point, is what the minimum or the maximum length. So that is our turning points there. So It's up to you. Use the first derivative or use the turning point formula. Here is the turning point formula. This is the turning point formula. It's up to you, or you can use the first principle, remember. So I can simply use the first principle, or you can use the turning point. Because you're at grade 12, I would like us to simply use, I'll just use this. Remember the equation that we had there, it's f of x is equal to x squared minus 3x minus 4. I will take f prime, multiply, they will have 2x minus 3. Then we know it's when the gradient is equal to 0. At the maximum, they will have 2x minus 3. Then we solve for x, take this to the other side, isn't it? So if you take this to the other side, this will be positive 3, then divide by 2. X will simply equals, you take this there, then you divide by 2 both sides. Right, this is what we have there, positive 3. Then remember they say they want what the coordinate. Let's find the value of y. We substitute this to the what original formula. Remember this, it's the original formula there. Then we can replace that to the original formula. Say 3 over 2 into 3 over 2 squared from this formula there, the original one, minus 3 over 2 minus 4. Therefore, so what you supposed can punch it this directly on your calculator without a waste of time. Our y value will be 25 over 4. Therefore, the coordinate of d, if I want the coordinate of d simply equals to 3 over 2 to minus 25 over 4. So here, so number 3, for which values of x will the gradient of the tangent, for which values of x will the gradient of the tangent to the graph f be negative? Okay, it's actually negative gradient. It's where the graph is decreasing. It's where the graph is decreasing. It's decreasing. That we know that we must supposed to check here our turning point is decreasing where the graph. Here, remember, from here to going upwards, the graph is increasing. Let's say you have a roller coaster. If you have a roller coaster there, the roller coaster will move like this, will decrease and decrease and decrease. When it reaches to that point, will go upwards. So I want us to check. Some learner asked me, so means this because even here is increasing, why don't we take this part? No. Remember, in mathematics, we read the graphs from the negative side to the positive. Remember the number line. This region is negative, this region is positive. So when you are reading or reading domains, or if you are reading we read from left to the right. We don't read from right to the left. That is the rules that we apply here at maths. So as you can see, this will decrease from here at these values of x. We know that the value there of x there is 3 over 2. So this graph will decrease from here up to infinity. The arrow shows that it contains will be this up to infinity. So it's up to you which way you prefer, using notation or into. It is up to you which process you want to use. I can say you know that x must be less than, as you have seen, must be less than 2 over 3, or someone can say I know will be from negative infinity, we're reading from negative there up to 3 over 2, like this. Is up to you which one. Or you can say x is an element if you want, like this. It's up to you which one you prefer there. So yeah, 4, find all the values of x for which the gradient of the tangent to f will be parallel to the line that we have given. What do we know about parallels? If we have parallels, that means the gradients will be equal, isn't it? The gradient of the graph and also the gradient of this stuff that we've given will be equal, because if we check here, so it find all the values of x for which the gradient to the tangent of f will be parallel to that. We know that even if we found that, so the gradient will be equal. Here, what is the gradient? Remember, this is a form of straight line. The gradient there will correspond to what? To -4. So the gradient there actual there must be -4, right? But let us take from this graph, we can take the first principle, but we know that gradient, we've taken it. Remember, we found this to be like that. Or let me just take it and let me take here. We took the first principle here. Then we have this. We had that 2x minus 3. If we differentiate that, that will be 2x minus 3. Remember, this is a gradient, guys. Derivative, first derivative will simply means gradient, guys. Gradient. That is just the fancy ways when we say derivatives. Derivative is what is equal to gradient. Simply just gradient. So we have here -4. Can solve for x there. If you take there, you have that. You go transpose to that side, isn't it? So then you divide by 2. Both sides you'll have -1/2. So this is what we'll have there. Our x value there. So question 4, we're given 5x minus 1 and 3x plus 1 and 2x are the first 3 terms of arithmetic sequence. Oh, find arithmetic sequence, which is, it's the same as a straight line. Find the numerical values of the first 3 terms of the sequence. Okay, it's fine. We know that actually t, we can start from here if you want. T3 will minus that, remember, must be equal, minus t2 must be equal, remember, to t2 minus t1. We know that the common difference must be equal. Then it's up to you which one you prefer. We can start by here. It's up to you, right? So here I'll have T3 is this one. Let me just show you guys. This is T3. This is T2, T1. So yeah, T3 is what is 2x minus. Remember, these are 2 terms. If you have 2 terms, you put your bracket or parentheses, x plus 1 like this. Then T2 again is 3x plus 1 minus, but you put your stuff there. This is what we have. Absolutely beautiful. Then we solve for maths. Distribute today, we'll have 2x minus 3x minus 1, 3x plus 1 minus 5x plus 1. Then you do your math. If you do math, there will be negative x minus 1, that there be minus 2x. Remember these 2, we'll have 2x. Then guys, just the maths now. What is left for you guys there? We are left with maths. We'll have there, if I take this, right? So this will be minus x right. Check there. Okay, what I'm doing, sorry guys. Then if you do your thing occurrence here, if multiplied, you'll get this minus x minus 3 there. Therefore x will simply equals to 3. What we want now, remember, where we'll substitute 3 here. Where you see x, you substitute 3. Where you see x, you substitute 3. Then we'll get, if you do like that, you're supposed to get that your sequence will simply equals to 14, 10, 6. You just take what you have there. Remember here we've given 5x minus 1. You replace there by 3, so on and on. 3 plus 1, 2, replace 3. Then this is what you'll have. If you multiply there, this is what you'll have there. So yeah, this is what we have, this sequence there. Right, and then the common, so they say right hand term, the general solution of this, so we can find the common difference. 14 minus by 10 will be 4. This is our d. So we know this is Tn is equals to a plus n minus 1 multiplied by common difference of first term, there's 14, and we don't know so far. Okay, it's 3, but we are not there. Multiplied by d, which is 4. Right, so 14 distribute there will be 4n minus 4, like this. Common difference is what? Second, why I'm doing this? I'm tired using. Is what is in this term minus this one. Yeah, I'm doing no sense now. This will be minus 4, and that will common difference will be minus 4. Well, I'm doing nonsense. Multiply there will be 14. Minus will be minus 4, and multiply there will be plus 4. But so this is same as 14 plus 14 minus 4 and plus that. When you add these two, you'll have 18 minus 4n. So yeah, let me check here guys what I've did. Yeah, everything is cool now. Remember this is our Tn. All right, then let's check question 5. Yeah, we have there question 5. This is determine the value of we've given the diagram below shows this f of x is equal to x cubed plus px squared plus 3x minus 9, and AC are the turning points of f, and AB are the x-intercept, or E is minus 5 over 3y is the turning point of inflection. All right, let's determine the value of P, whereby the P is here. All right. So I've given the point of inflection here. Want that? Okay, we can take that the second derivative. Point of inflection is the second derivative, but there we know we have f of x to be equals to x cubed plus px squared, as we are given there, plus 3x minus 9. So by the way, here we have also E, which is there. We know this point is like the point in the graph, is the point in the graph that we know. Let us take advantage of this point. Remember, it's the point here, there, right? We'll take advantage of that point. You understand? So that point E, we'll take advantage of it. So since it's a point in the graph, we can say first derivative of that will be just multiply 3 divided minus 2. With minus 1 you have 2, multiply there will be 2px plus 3. Then second derivative we'll have 6x plus 2 p. Why I'm saying 2p. Then let us take advantage of the turning point. Remember this now, it's an inflection point, it's at the second derivative. You can take advantage of that. We take advantage of that, but we know we can say this is 0. There we know the point of inflection, then substitute 5 over 3, it's x right, plus 2p. We're taking advantage now. Then just take these guys there, then divide by 2, find out p will be equals to 5. Upon that, we have taken advantage of what we know. So b, but if p is equal to 5, we found that even they give you, you say these people, they even, you say obvious, if you did not get 5, that means you'll be seeing that you are wrong. They show you the simple, is like a hint there. They even give you, they say calculate the coordinate of turning point. See, without looking, we know the coordinate of turning point. The coordinate of turning point is when the first derivative is equals to 0, right? So yeah, let us take where actually we're supposed to take that first derivative there, but but we've given f of x when x is 5. We can rewrite the original one, x squared plus we had p, but p now will be 5. Yeah, we had p, but p will be 5. What is this? Must be cubed. What I'm doing now is a quadratic. Cubed plus 5x squared plus 3x minus 9. Then take the first derivative, multiply there. My question is that, let me check the original formula. Why it seems like here, where was this original? Oh, here it is original. Here, actual. Don't want to do some silly mistake. Here it is original there that we have given. Let me substitute that 5, isn't it? We have x cubed, p by set is 5, this is 5, here we have 5, x squared plus 3x minus 9. So that I won't do some silly mistake, then I'll drop, there will be 3 squared 10 plus 3. Definitely this is equals to 0. Then factorizing 3x, I can multiply this by x, I know, but the factors must be plus 1 plus 3. This is what you'll have when you multiply this, will give you 3, isn't it? Therefore 3x plus 1 is equal to 0, or x plus 3 is equal to 0. X will be equals to minus 1 divided by 3. So remember, the aim was to finding the turning point. Then we'll substitute this into our original equation, isn't it? My question, you'll use this or you'll use this? Let us evaluate. You can evaluate there. Yes, you can check. Turning point, this must be low, must be less there. So we'll use minus 1 over that. So our original formula, if you substitute minus 1 over 3, remember these turning points, the other one is here, lower there to see. So we'll use this because we want that coordinated C, isn't it? So when you substitute this cubed plus 5 to the original formula, so we'll get this to be equals to what? What is the value of y? Punch that would be 1,256 over 27. Then we know, therefore, coordinated C is simply equals to 1 over 3 negative 1 over 3, 256 over 27. So it be the x-intercept here, guys. It's up to you which one you prefer to use there, long division or what. But okay, we have this original thing there. Want the value of x coordinate. Can find the fact. Try and put 1 1 1 and check if this will be equal to 0. That will be our fact. I'll try to substitute x. I will try to estimate these values here. I don't know which one, but I'll try this to see what is our factor there. Minus 2 cubed, try minus 2 cubed plus 5 minus 2 squared plus 3 minus 2 minus 9. This is not a factor. Then I'm trying minus 1 now. Trying minus 1 again. I replace -1, this is not a factor. Let's check. Let me put 0. If I put 0 here, 0 won't be a factor. Let me try and replace 1 where I see x. I want the factors there. That means the factor it's 1 is this is 1. So since it's 1, we know this will write as 1 minus 1. Remember, it's a fact. So you can use long division. Our device, our factor there, then our original form there will be like this. So how do you do long division? The first one, you see what you see here. The first, you divide by this, then right. If you divide that, you will give you what? You will get x divided by x cubed divided by x. You'll get what? X squared. Then you write it here on the top. You'll have x squared like this, right? Then that is what we have, right? Then here we put a bracket. You do like this. You multiply by this here. Both those bracket will be what? If you multiply there, will be x cubed. Then there will be minus x squared. Then you draw a line. Always put the negative here and put the bracket. Then if you distribute, this will be minus negative x cubed. If this will be positive, you see. So minus, now you add x cubed minus x cubed will simply equals to what? 0. This one, when you multiply, they will be positive. Then you add, this will be plus 6x squared like this. Then you drop those ones down, have plus 3 minus 3. Then you repeat the process again. The first one, 6x squared divided by this x here. Always, if you divide by x, you'll have 6x. You take this to the top, you write it here on the top, plus 6x. You multiply also there on the brackets. If you multiply there, remember, you put your minus here, put the bracket, you multiply again. 6 multiplied by this will be 6x squared. 6 multiplied by -1 will be minus 6x. Then you draw your line, but multiply that will be minus 6. Then you add minus 6 and minus 6 will be 0. You distributed that. Plus 6 plus 3 will be plus 9x. You bring that down. You repeat the process again. 9x divided by x. Again, simply have what? 9. You write this 9 here, plus 9. You multiply there again on that bracket, but do not forget the minus is always here. Will be 9x. If you multiply there, will be 9x. Multiply all 9, positive 9 minus 1 will be minus 9. Right, will be minus 9. Then this and this will be 0. Then you add there, will have plus added guy there, will have minus 9 plus that there. So as you can see, what do we have there now? We have these factors of 6 and that of these two. Then you factorize this. As you factorize bx minus 1 x whatever can I multiply there, 3 multiplied by 3, 3 multiplied by 3. Let's check now. Here, let me write it here. Take what we have there. Use any method that you prefer. X minus 1. If you factorize this, it's x plus 3. Yeah, so this is the same as, because these are the same, you can write that as x minus 1 and x plus 3 cubed, like this. This also, they say they want what, or the x coordinate, that's fine. If you want the x coordinate, remember this will equate to 0, all of this. Then x will simply equals to 1, x will be equals to minus 3, x will be equals to minus 3. So yeah, then obviously x coordinate is simply 1, 0, minus 3, 0. This is a table, minus 3, 0. So guys, thank you guys for watching. I will end here for today due to the battery. If you have subscribed, we will continue with question 6. We'll continue with this paper throughout. So make sure that you have subscribed, and thank you for watching, guys. You can share this to your fellow classmates. You can like and comment. If you have found this video helpful, click that notification bell there. All the best.